So in this video, I'm going to go over the Mach 7 review today, guys. So let me move this up here so I can move the screen. All right, so the first question says rewrite each expression in radical form. So recall that if we have a negative exponent, it's going to move the equation to the denominator, right? So I'm going to put my y underneath here because that is my base. My base becomes my radicand. Then remember also that the index is the denominator. So that this is our denominator right here, a, so that's going to be my index. And 4 is going to be my exponent. My numerator is going to be my exponent. All right, so for b, I'm going to write this in 1 minus 4/3. Remember, anything that's in the denominator is negative. So if you do this in your calculator, you get 8 to the negative 1/3. And that's going to be what? Again, we're going to write this in radical form, so it's going to be 1 over our 8 is our, again, base, so it's going to be our radicand, and our 3 is our denominator, so it's going to be our index. So this last one over here, c, again, it's going to be 1 over the square root of 10, the square root of negative 10, sorry. And if there is nothing over there as the radicand, as the index, that would be our 2, right? And then b is our exponent, okay? So the next one, number 2, a, b, and c, says rewrite each expression in exponential form. So when I do this, I'm going to write them y to the 13 over 2. Remember, if there's nothing here, there's a 2, right? And then times y to the 7 over 2. So this is going to be y to the 13 over 2 plus 7 over 2. That's going to give us y to the 20 over 2, and 20 divided by 2 is what, y'all? Yes, y to the 10th, okay? So the next one I'm going to write in exponential form, and then I'm going to simplify it. So this is going to be c. Again, remember that our index is our denominator, so this is going to be 5/4. And then we're going to subtract what's down here. So this is going to be 3 over 1 times 3 over 4. That's 3 times 3, so that's going to be minus 9 over 4, because 1 times 4 is 4. Okay, so this is going to be c to the negative 4 over 4. What is 4 over 4? That's 1, so this is equal to c to the negative 1. So our answer is going to be 1 over c. All right, so this next one, okay, we're going to talk about this. We're going to deal with the 5s and the 7s, okay? So once again, what's in the numerator, I'm going to write it in exponential form. So it's going to be 5 to the, again, 2 over 3. And we're going to subtract what's in the denominator. That's minus 4 over 3. Okay, and then with the 7, we're going to do 7 to the 4 over 5. And remember, it's minus a minus 3 over 5. So when we have two negatives next to each other, what do? We add, right? So we're going to add those, okay? So this answer is going to be 5 to the negative 2 over 3 times 7 to the 7 over 5, right? Remember, that negative goes to the denominator. So our answer is going to be 7 to the 7 over 5 over the 5 to the 2/3 power, okay? That would be our answer, 7 over 5, and for our exponent of our 7, and 5 to the 2/3 in our denominator because it was negative. So this next one, we're going to write it. Notice all our answers are in exponential form, so we're going to go ahead and write it in exponential form. So we're going to say, and remember, if there's nothing as an index, there's a 2 as the index, right? So this is going to be b to the 12 over 2. And remember, if it's in the denominator, it's going to be negative, and that's going to be b to the negative 3 over 2, right? So we're going to subtract. So it's going to be b to the 12 over 2 minus 3 over 2. That's going to give us b to the 9 over 2. That was our answer. Okay, so this next one says when f is greater than 0 and g is a positive integer. And this was a 3 up here, y'all. It didn't come through on my thing. F to the negative 3 over g is equivalent to which of the following expressions? Well, remember, if we have a negative exponent, then we know that our radical is going to end up in our denominator. So we already know that these can't be our answers, right? Remember, again, the 3 is our exponent. The g, the denominator, is our index, right? So this is our answer because g is our index. Y'all see that? The g right here goes right there. That's what it was, okay? All right, so on this next one, we're going to go ahead and say the square root of 7x. We're going to subtract the 12 from both sides, right? So that's going to be 14. What are we going to do to both sides? We're going to square both sides. So this is going to be 7x equals 196, and then we're going to divide both sides by 7. So x is equal to 28. Do not forget to put the 28 back up in there. 7 times 28 is 196. 196, the square root of 196 is 14. 14 plus 12 is 26. So that answer checks out, okay? So on the next one, we're going to move that radical to the other side first. So it's going to be the cube root of x plus 6 equals, and we would add it to get it to the other side, right? So this is going to be 3x minus 1. So now we're going to cube both sides, right? Cube. So that's going to give me x plus 6 equals 3x minus 1. Subtract x here. Add 1 to both sides. So that's gone from there. And this is gone from there. So we're left with 7 equals 3x. No, 2x, sorry. So we subtract the x from the 3x. Going to divide by 2. So x equals 7 over 2, or 3 halves, or 3.5, right? These are equivalent answers, right? Okay, so that would be this answer. Now I want to show you guys how to do this in Desmos. So I'm in Desmos, and I'm going to put a cube root, one of the cube roots here and one of the cube roots there. Okay, so I'm going to go here, over to functions, scroll down to where it says this, and I'm going to make this the third root, and I'm going to put my first function, x plus 6, here. X plus 6, right? And then I'm going to put my other function on this on the other side of the equal sign now here. So once again, I'm going to go to functions, scroll down to cube, or where I can put my cube root. And this time I'm going to put 3x minus 1. Whoops. Put it as the exponent. Or as the index. 3x minus 1. Okay. So do you notice we have an intersection point? The x value of that intersection point is the same answer we just got. So you can also get your answers when you can put them on both sides of the equal sign. You can put both of those equations in here, and you can find where they intersect. Just remember, guys, that 7 over 2 is the same thing as 3.5, right? Okay. Now, on this one, again, we can do the same thing here that we did a minute ago, but I'm going to go ahead and solve it. So I'm going to square both sides. So this is going to be 11x minus 28 equals x squared. Move everything to the right. 0 equals x squared minus 11x plus 28. Going to factor this. So this is x minus 7, x minus 4. Set those equal to 0. So this is going to be x equals positive 7 and x equals positive 4, right? Okay. So mind you, we got to put both of these back up in there and check them. Okay. So 11 times 7 is 77. 77 minus 28 is 49. The square root of 49 is 7, and that equals 7. Okay. Here, 11 times 4 is 44. 44 minus 28 is 16. The square root of 16 is 4. So 4 equals 4. So once again, let me show you how to do this in Desmos. So this time we're going to put our square root in here, and we're going to do the square root of 11x minus 28. And then here we're just going to put our x. So here again, notice, what is the intersection point of this? It was 4. And look up here, it's also 7. Okay. So what's key here is if there's 2 intersection points, then we know that there are 2 answers. Y'all see that? Okay. So that's how you can check them. Now in questions like number 7, we can't check them like that, okay? So we're going to have to move this 6 to both sides, or to the other side. So this is going to be x minus 7 equals 6, right? And then we're going to take the square both of those sides. So this is going to be x minus 7 equals 36, and then we're going to add 7 to both sides. So this is x equals 43. Put that 43 back up in there. 43 minus 7 is 36. The square root of 36 is 6, and 6 minus 6 is 0, okay? So down here, now this one's a little, we can check this one and the next one in our Desmos, okay? So we're going to subtract 21 from both sides first. So that's going to give us the square root of 5 minus 4x equals just x, right? So now we're going to square both sides. So this is going to give us 5 minus 4x equals x squared. Subtract our 5 and add our 4x to both sides. That's going to give us 0 equals x squared plus 4x minus 5. So we want to find the factors of 5 that add up to be 4. So that's going to be x plus 5 and x minus 1, right? Set those equal to 0. So this is going to be x equals negative 5 and x equals positive 1, right? So here again, we must check both of these, okay? So, and when we put negative 5 up there, so if we put 4 times a negative 5, that would be the square root of, so that's going to be 5 plus 20, right? So that's the square root of 25. The square root of 25 is 5. 5 plus 21 is 26, right? But if we put a negative 5 over here, that's going to be 16. So this cannot be an answer. Now, if we put the 1 back up there, let's put the 1 up there. So 4 times 1, and this would be plus 1. Okay, so that would be now 5 minus 4, which would be 1. Square root of 1 is 1, and 1 plus 21 is 22, and 1 plus 21 is 22. So this would be our answer. We're going to check it in a second. After we've solved them, we're going to check it in Desmos, okay? So here again, we're going to square both sides. That's our first step, right? Remember, we're going to use the box method to square the x minus 4. So this is going to be 4x minus 19 equals x squared minus 8x plus 16. I'm going to subtract the 4x from both sides. I'm going to add 19 to both sides. So those are gone. So I'm left with 0 over here. This is x squared minus 12x plus 35. Now we're looking for the factors of 35 that equal negative 12. So that's going to be x minus 5 and x minus 7. Set those equal to 0. So this is going to be x equals 5, and this is going to be x equals 7, right? Now, again, we got to check these. 5 times 4 is 20. 20 minus 19 is 1. Square root of 1 is 1, and 5 minus 4 is 1. So this one checks out. And then if we do 7 times 4, that's 28. 28 minus 19 is, what is that, 9? And the square root of 9 is 3, and 7 minus 4 is 3. So both of these check out. So now let's check these again in Desmos. So number 8, we're going to put our square root in here. Square root of 5x minus 4, 5 minus 4x, 5 minus 4x. And then for this other one, we're just going to put x, because remember we subtracted the 21. Now you could say plus 21 here, right? And then over here you could say x plus 21. You could put it in just exactly the way it is. And you're going to have to scroll out to see the answer to this one. Y'all see it right there? So the only answer is 1. Y'all see it? Okay. All right, now let's check the other one. So the other one, we did have 2 separate things on different sides of the equal sign. So in this one, we did on the other one too, but it was a little tricky, maybe in y'all's minds, okay? So on this one, and then we're going to put x minus 4 here. Now notice, I'm going to zoom in, okay? And you guys might want to do this, zoom in, okay? So once again, I see that this intersects twice. Y'all see it? It intersects at 5, and it also intersects at 7. And those were our 2 answers, okay? So now with problems like 10 and 11, we can't use Desmos to do what we just did, okay? So we're going to actually subtract 10 from both sides. So this is going to be 4 equals 2 times x minus 15 to the 1/3 power. Then we're going to divide both sides by 2. So this is going to be 2. Sorry about that. Equals x minus 15. Now, hopefully you remember the way we get rid of a 1/3 is multiplying by its reciprocal, which is 3. And we have to do that on both sides. So this is going to be 8 equals x minus 15. Then we add the 15 to both sides, so x is equal to 23. And again, if I check it, 23 minus 15 is 8. If I take 8 to the 1/3 power, I get 2. 2 times 2 is 4, and 4 plus 10 is 14. Okay, so it checks out. Check them, guys. Make sure you do, okay? So here again, we're going to do the reciprocal of the 2/3, which is 3/2. And in your calculator, guys, you can do 4 to the 3 divided by 2 power, okay? And it's going to give you that is 8. So 8x plus 5 equals 8. Subtract 5 from both sides. 8x equals 3. Divide both sides by 8. So that's our answer right there. And again, you can plug it up in there because 3/8 times 8 is 3. 3 plus 5 is 8, right? And then 2/3, take an 8 to 2/3 power, you're going to get 4. Okay, so you can double check it there. So now this one right here, we are going to square both sides, right? So this is going to be negative 5x plus 34 equals x squared. Use the box method again, right? So we're going to subtract, we're going to add 5x to both sides, and we're going to subtract 34 from both sides. So now that's gone and that's gone. So we got 0 equals x squared minus 11x plus 30. So that's going to be x minus 5 and x minus 6, right? Set those equal to 0. So that's going to be x equals 5 and x equals 6. So now we got to plug those back up in there. So if we do negative 5 times 5 plus 34, right, and set that equal to 5 minus 8, this is going to be negative 25 plus 34. That's going to be 9, right, y'all? So that's square root of 9. And this is a negative 3, right? So 3 does not equal negative 3, right? Okay, let's do the other one. I'm going to scroll down just a little bit over here and do it. We'll do it right over here, maybe, if I can fit it. So I'm going to do, again, negative 5 times 6 plus 34. Does that equal negative 5? Sorry, 6. Whoa, what did I do? 6 minus 8. Okay, so this is going to be negative 30 plus 4, 34. So that's going to be the square root of 4. This is going to be negative 2, right, y'all? So this is going to be 2, and again, it does not equal negative 2. Do y'all notice that? So this one has no solution. So I want to show y'all this one in Desmos. So here we go. We're going to put the square root of negative 5x, negative 5x plus 34, and then we're going to put our other equation right here, x minus 8. Look at that. They never intersect, y'all. And because they never intersect, that's what tells me there is no solution. Okay? Okay, here are our word problems. So the formula for finding the side length of a metal cube given mass and density is S is equal to the cube root of m divided by d, where S is the side length of the cube in centimeters, m is the mass in grams, d is the density of the metal cube. If the gold metal cube has a mass of 1200, and I notice that mass is on the top, so I'm going to put the 1200 on the top, and the density, that goes on the bottom, what is the side length? So we're solving for S, right? So then we're going to take the cube root of this. So I'm going to find what is 1200 divided by 19.3. And when I did that, I got 62.176. And I would just leave this in my calculator and then take that to the 1/3 power. Why? Because the cube root is equal to the 1/3 power. So when I did that, I got 3.96, and it says to the nearest centimeter, right? So it's going to be 4 centimeters is your answer, okay? The next one, the height of a free-falling object is given by h is equal to v squared over 2g, where h is the height of the meters, v is velocity, g is acceleration due to gravity in meters per second squared. H is the distance in meters that the object has fallen. The value of g depends on which body planet. If an object on the moon falls a height of, okay, so that's our height, right? So that's going to be 31.85, and it equals where the gravity is 1.57. So v squared is going to be 2 times 1.57, right? At which velocity? So v is still there. So just asking us what the velocity is, right? So we're going to multiply 2 times 1.57. So that's going to be equal to 31.85 equals v squared over 3.14. How do we get rid of something in the denominator? We multiply both sides by it, right? So that's what we're going to do. When I do that, I get 100.009 equals v squared. Well, I don't want v squared, I want v. Okay, so I'm going to have to take the square root of the v squared and the 100, and we know that the square root of 100.009 is 10, right? So that's going to equal our velocity, and that's going to be meters per second. All right, now this last one down here says electric power can be defined by the equation in terms of current in terms of, let me erase that so you guys can see that, because I don't think y'all can see that. I can't see it. P equals I squared R. What is the equation for the current in terms of power? Now, I don't know about y'all, but current in terms of power, when they haven't defined any of these variables for me, is a little confusing. But if I look at the answers, I see I, right? So let's just solve for I. So when we do that, we got P equals I squared R. So I'm going to divide both sides by R, aren't I? So that's going to get me I squared equals P divided by R. Now what do I have to do to get I by itself? Take the square root, right? So that's going to be my answer, because now the I squared is just I. So the answer is D. All right. So let's talk about these next ones, okay? So if the parent function of x is the cube root of x is translated 3 down, that's a what? K, right, y'all? Stretched horizontally by a factor of 4. So this is going to be our b. And remember, if this is our b, guys, we always change b, right? Horizontals under the square root, okay, or under the radical. We'll say it there. Everything horizontal is under the radical. Everything outside the radical is vertical, okay? So remember, we're always going to change this, right? Anything that's underneath that radical, we're going to change it. And then it says it's translated left. So that's also underneath our radical. So that means we're actually going to put, left would be minus 5, right? So we're going to put a plus 5. And this is our, what? H, okay? So K is equal to 3. So then all we're doing is looking to see where we have whatever, right? So B is underneath the radical, isn't it? Now, I want to point something out to y'all. These all should have had parentheses here, okay, in our answer choices. So when we look at this, it's a cube root function. So all 4 of them are cube root functions. So that doesn't help us eliminate anything. We know the 4 can't be out front because that's a vertical stretch, right? And if it's a vertical stretch, then we know it's going to change to 1/4, right? So it can't be C as well. Then we're looking at our K being 3 down. So that should have been, sorry, I should have put minus in front of that, y'all, because it was 3 down. So this should be minus 3 equals K. So that's true of both of them, right? But then we have a plus 5 as our, so our answer was B. Okay? All right, now 17. If the parent function is a square root, and it's translated 2 to the right, so this is going to be what? Minus 2, that's going to be our H, because remember, it's always going to be opposite. Left, right is underneath the radical. That's a horizontal change. Compressed vertically by a factor of 1/3, this is our A. Translated 1 up, so this is going to be our K, and that's going to be plus 1, right? And reflected across the x-axis. So if it's reflected across the x-axis, then our A is going to be negative, right? So that means our A is going to be what? A is going to be negative 1/3, right? So can't be this one, can't be this one. Then we've got, it's minus 2 and plus 1. So are we looking for a minus 2 for H and a plus 1 for K? So our answer here is A. Okay? All right, so let's go on to the next one. Which equation represents the given graph? Okay, so this is a cube root function. So remember, this point right here would normally be, because it's where the graph goes up and down, or down and up, doesn't matter which one, but where it transitions, okay? That would normally be over here. So that means it moved how far? Didn't it mean move 4 to the left? Which would be what? That would be H, and H would be a minus 4, which means when we put it in the equation, it would be a plus 4, right? So what we're looking for is an H with a plus 4. So that is a cube root function, because this is a cube root graph. So we know it's not this one, because that's a square root graph. So it has to be this one, right? Because this one is K, C is K, and that's a minus 4, okay? So the next one says, given the equation, identify the transformation. So we got a 1/5 out front, so that's got to be a vertical what? Vertical stretch, or no, compression, right? Vertical compression, or we could also call it a shrink, right? Sorry, I'm writing too fast. Trying to get through this quickly, y'all. Vertical compression or shrink by a factor of 1/5. Okay, then what is that minus out front? Okay, so, we better pause a second. Okay, so y'all notice this? If that's that way, then we want to factor out a -1 first. So let's go ahead and do that underneath that radical. Do a -1 times x plus 3. Y'all, we want to factor that first if we can, okay? So what does that -1 out front mean? Doesn't that mean, again, remember, these are horizontal changes, so this is going to be a reflection over the, what? Y-axis, right? Okay, and then what does that plus 3 tell us? 3 to the left, remember, is always going to be opposite of what we expect underneath that radical, okay? All right, 20 says, what is the domain and range of the function? Okay, so here we want to look at where does the point of the graph start? So that's at 7, 2, right? And the arrow's pointing to the left. So we want to find, do we have 7 and 2? No. We do have 7 and 2 for B. We don't have 7 and 2 for C, because remember, this is X and Y, right? Which is H and K. So we do have 7 and 2 for the D as well. So now we're looking at where do the arrows point. Now, obviously, our X values are getting smaller, so this one checks out for both, right? What's happening to our Y values, though? Are they getting bigger or smaller? They're going down, aren't they, guys? So it's going to be less than or equal to. So it's going to be this one, because otherwise it's getting bigger, okay? So the last, number 21 down here, says what is the domain and range of the function? So this is a cube root function. Do y'all remember? Domain is all real numbers and range is all real numbers for cube root functions. Because remember, those graphs look like this, right? And it keeps going up and down and it keeps going left and right. All right, this one says describe the given characteristics of the function graph. So and behavior. So we're looking as x approaches infinity. That's over here. Doesn't the graph stop right there, y'all? So what is our y value? That's f of x, right? Y and f of x are interchangeable. F of x approaches what? 0, right? And then as x approaches negative infinity, now we're going this direction. Where's that graph headed, y'all? Yep, to infinity. Okay? Now, domain. So our domain is going to be our x value. So x is, where's the arrow pointing? To the left. And what is this h and k? So this h is 3 and our k is 0, right? So those are going to affect our domain and range, right? X and y. So that's going to be 3. And what's happening to our y values? Are they getting bigger or smaller? So our y's are going to be greater than or equal to 0. Now, what's happening to this graph? We want to jump on this graph over here at the left, and we want to ride it. Was it going up or down? Right, it's going down. So this is none. And the interval of decrease is from out here at negative infinity to where right here? What's this point right here? 3. Yeah, so it's going to be from negative infinity to 3. So from negative infinity to 3. Remember, parenthesis, bracket, okay? Then this one says, which statement is false about the function graph? The graph increases on the interval from negative infinity to infinity. Does this graph increase? Get on the graph at the left and ride it. It's like a roller coaster ride, right? Is it going up or down, y'all? It's going down, so it's definitely not increasing. The domain of the graph is from negative infinity to infinity. Well, that is true. Now, let's just keep going just to make sure none of the rest of them are right. Oh, wait. This is false. Y'all see that? I just caught that word. Y'all should catch that word. Let's go back. The graph increases. Well, no, it doesn't. So guess what? That was our answer right there, y'all. Let's keep going, though. The domain of the function, that is true. As x goes to infinity, as we're going this way, the graph is headed towards negative infinity, isn't it, down here? So that's true as well. As x goes to negative infinity over here, where's the graph headed up here? Towards infinity up there, right? So that is true. So on a question like this, yeah, you better catch that word false, okay, guys?